Application controls include policies and procedures associated with user activities and the automated controls designed into applications. Controls should be in place to address both batch and online environments. Standards should address procedures to ensure management appropriately approves and control overrides. Refer to the IT Handbook's Operations booklet for details relating to operational controls. Designing appropriate security, audit, and automated controls into applications is a challenging task. Often, because of the complexity of data flows, program logic, client-server connections, and network interfaces, organizations cannot identify the exact type and placement of the features until interrelated functions are identified in the design and development phases. However, the security, integrity, and reliability of an application is enhanced if management considers security, audit, and automated control features at the onset of a project and includes them as soon as possible in application and system designs. Adding controls late in the development process or when applications are in production is more expensive, time-consuming, and usually results in less effective controls. Standards should be in place to ensure end users, network administrators, auditors, and security personnel are appropriately involved during initial project phases. Their involvement enhances a project manager's ability to define and incorporate security, audit, and control requirements. The same groups should be involved throughout a project's life cycle to assist in refining and testing the features as projects progress. Application control standards enhance the security, integrity, and reliability of automated systems by ensuring input, processed, and output information is authorized, accurate, complete, and secure. Controls are usually categorized as preventative, detective, or corrective. Preventative controls are designed to prevent unauthorized or invalid data entries. Detective controls help identify unauthorized or invalid entries. Corrective controls assist in recovering from unwanted occurrences. Automated input controls help ensure employees accurately input information, systems properly record input, and systems either reject or accept and record input errors for later review and correction. Examples of automated input controls include, check digits are numbers produced by mathematical calculations performed on input data such as account numbers. The calculation confirms the accuracy of input by verifying the calculated number against other data in the input data, typically the final digit. Completeness checks. Completeness checks confirm that blank fields are not input and that cumulative input matches control totals. Duplication checks confirm that duplicate information is not input. Limit checks confirm that a value does not exceed predefined limits. Range checks confirm that a value is within a predefined range of parameters. Reasonableness checks confirm that a value meets predefined criteria. Sequence checks confirm that a value is sequentially input or processed. Validity checks confirm that a value conforms to valid input criteria. Automated processing controls help ensure systems accurately process and record information and either reject or process and record errors for later review and correction. Processing includes merging files, modifying data, updating master files, and performing file maintenance. Examples of automated processing controls include, batch controls verify processed run totals against input control totals. Batches are verified against various items such as total dollars, items, or documents processed. Error reports identify items or batches that include errors. Items or batches with errors are withheld from processing, posted to a suspense account until corrected, or processed and flagged for later correction. Users verify log transactions against source documents. Administrators use transaction logs to track errors, user actions, resource usage, and unauthorized access. Run-to-run totals compiled during input, processing, and output stages are verified against each other. Sequence checks identify or reject missing or duplicate entries. Operators revert to automatically created interim files to validate the accuracy, validity, and completeness of processed data. Backup files. Operators revert to automatically created master file backups if transaction processing corrupts the master file. Automated output controls help ensure systems securely maintain and properly distribute processed information. Examples of automated output controls include, batch logs record batch totals. Recipients of distributed output verify the output against processed batch log totals. Distribution controls help ensure output is only distributed to authorized individuals. Automated distribution lists and access restrictions on information stored electronically or spooled to printers are examples of distribution controls. Destruction controls help ensure electronically distributed and stored information is destroyed appropriately by overriding outdated information or demagnetizing, degaussing, disks and tapes. Refer to the IT Handbook's Information Security booklet for more information on disposal of media.